All right, welcome to my tutorial. Today we're going to be talking about reflections, but let's go ahead and review a couple of things. Right now we're talking about transformations. In a transformation we have a pre-image, which is the original, and we're going to change it, transform it to an image, which is the copy. And again, there are rigid transformations which do not change the size or shape of the pre-image. In other words, they are congruent. And there are non-rigid transformations will change the size but not the shape of the pre-image, which are not congruent. And there are four types of transformation that we're going to deal with. Three of them are rigid and one is non-rigid. And once again, here we go. Rigid transformation is when an image is congruent to its original figure. It is congruent, so the size and the shape are preserved. While a non-rigid is a transformation that does not preserve the shape and the size, so it is not congruent. Today, we're going to talk about reflection. That's when you flip an object across a line without changing its size or shape, and that's a rigid transformation. In the old days, they would call it a flip. And the type we're going to be doing are going to be flipping either across the x-axis or the y-axis. And so here you can see vertical axis, which is the y-axis, and the blue shape is being flipped across. So the y-axis is kind of acting like a mirror. So it's kind of reflecting across the y-axis. So let's go ahead and get started. Here, we're going to draw the image after the figure is reflected across the y-axis. Now, first of all, what is the coordinate notation? Well, in a reflection across, the x-axis, we're going to be reflecting across the x-axis, the x value is going to stay the same. Very important you know that. When you reflect across the x-axis, the x value is going to stay the same. Now, what happens to the y value? Well, the y value is going to become the opposite. And we show opposite by multiplying by -1. It does not mean that y is going to be negative. The negative in front means it's going to be the opposite of y. So the first way I'm going to show you how to do a reflection across the x-axis is by graphing. So we're going to start off with the x-axis and we're going to reflect across it. So what you're going to do here with vertex O, we're going to count, because we're reflecting across the x-axis, how many units it is away from the x-axis. So let's go ahead and count. We got 1, 2. So vertex O is 2 units away from the x-axis. So we're going to go, because we're going to reflect, 2 units the opposite way, and we're going to go ahead and label that O prime. All right, let's try that now with another vertex. Let's try vertex P. We're going to count, because we're reflecting across the x-axis, how many units vertex P is from the x-axis. And then we're going to go the same exact amount of units the opposite way, and that's we're going to plot vertex P prime. Now, in the image, in the pre-image, we got a line segment OP, and so we're going to make a line segment O prime, P prime, and those line segments are congruent. All right, let's do another point. Let's go ahead and do Q. Again, we're reflecting across the x-axis. So we're going to count how many units vertex Q is away from the x-axis and go the opposite way and label that Q prime. And now we're going to connect our line segments that correspond to the pre-image. And then we're going to do vertex R. Now, R is a little bit confusing. All our points are below the x-axis. This one, all our vertices are above the x-axis, and so when we reflect, we go below the x-axis. But R is below the x-axis in the pre-image, and so the image, we have to go above the x-axis. So R is 1 unit away from the x-axis, so we're going to go the opposite way, and that's where we end up with R prime. Now, for some people, it gets a little confusing because they overlap. Just make sure you count how many units and go the opposite way. Then we connect our line segments. Here we got line segment OR, and we're going to connect that. And so we have our image and our pre-image. And as you can tell in this reflection across the x-axis, both shapes are congruent. And here you can see that the O, all the vertices on the image and the pre-image, they all have the exact same X values. So the X value doesn't change. The only thing that changes is the Y values, and they become the opposites. All right, let's try, well, first of all, they're congruent shapes. I forgot to write that down. And this is an example of a rigid transformation. A reflection across the x-axis is a rigid transformation. All right, let's do another one. Here we're going to reflect across the y-axis. Now, when we do a reflection across the y-axis, the y value is going to stay the same. Now, what's going to happen to the x-coordinate? Well, the x-coordinate is going to become the opposite. Again, we show the opposite of x by multiplying by -1, and that's where we get the negative x from. All right, so let's go ahead and reflect this polygon across the y-axis. So we're going to start off, here's the y-axis, and this is what we're going to count how many units each vertice is away from the y-axis, because that's what we're reflecting upon. That's, in other words, that's our mirror. So let's start off with vertex C. How many units across from the y-axis is vertex C? Because we're reflecting across the y-axis, it's 2. And so we count 2 units the opposite way, and we go ahead and label that C prime. Let's go ahead and do B, vertex B. Because we're reflecting across the y-axis, how many units is B away from the y-axis? So we count 1, 2, 3, 4, 5, 6. And so we go 6 units the opposite way and label it B prime. And we're going to continue to connect our vertices, and we're going to continue with E, count how many units away it is from the y-axis, and go the opposite way, the exact same number of units, and label that E prime. Connect our vertices, and now vertex D is a little tricky. Since we're reflecting across the y-axis, D is on the y-axis. So how many units away from the y-axis is D? Think about that. Well, since it's on the y-axis, it is 0 units away from the y-axis. And so D, the reflection, is going to be the exact same point, and we're going to label that D prime. And so now we connect our vertices, and as you can see, all the y values are the same for each vertex. And so on this shape, which is a reflection across the y-axis, we end up with a rigid transformation, and the two shapes are congruent. In other words, the shape does not change in size. All right, let's go ahead and now do a reflection using coordinates of the vertices. Now, we're going to reflect across the y-axis. Earlier I told you, when you reflect across the y-axis, what's going to happen to the y value? Well, since we're reflecting across the y value, the y-axis, the y-coordinate is going to stay the same. And then the x-coordinate, just like before, the x-coordinate is going to become the opposite, and so we multiply it by -1. All right? So here are our vertices. We got vertex C, A, vertex B, and vertex C. And we're going to start off by writing our coordinate notation. And this acts as our guide, kind of like an equation. And so we're going to substitute our values appropriately. So let's start off with vertex C. We got the order pair 1, 5. That's going to give us Z prime. And so we're reflecting across the y-axis. So the y value is 5, and it's going to stay the same as 5. Now the x value is 1. And because it's positive 1, and in the reflection, the x value becomes the opposite, we're going to make it into -1. All right? So the y value stayed the same, and the x value became the opposite. So originally we had the order pair 1, 5. Now we have the order pair -1, 5. All right, let's go ahead and do vertex A. We have the order pair 7, 7, and we're going to go ahead and figure out A prime. A reflection across the y-axis, the y value is 7, so it's going to stay the same. Our x value is going to become the opposite, and so originally it was 7, and now on the image it's going to be -7. Okay? Now, negative x does not mean that x is going to be negative. And so we're going to see that in a couple of seconds. All right, let's do vertex B. We're going to figure out what B prime is. Reflection across the y-axis, the y value is -4, so it's going to stay the same. The x value is 3, and because it becomes the opposite, it's going to become -3. And here is the C vertex, which is the order pair -7, -6. Again, reflection across the y-axis. The y value is -6, so it's going to stay the same. And the x value is -7. But because x becomes the opposite, well, what's the opposite of -7? It becomes +7. And as you can see, the negative x does not mean that x is always going to be negative. It's going to become the opposite of the x coordinate in your pre-image on your vertex. All right, so let's go ahead and try a reflection across the x-axis. So reflection across the x-axis, the x value is going to stay the same. And then the y value is going to become the opposite, and we indicate that by putting a -y, which means multiplying by -1. Now that we got our coordinate notation, we write it down. That's our formula. We're going to use it as our guide. The x value is going to stay the same in a reflection across the y-axis, and the y value is going to become the opposite. All right, so let's go ahead and start with vertex G, which is the order pair 1, 0. Reflection across the x-axis, the x value is going to stay the same, so the x value is 1. And then the y value is going to become the opposite. And the opposite of 0, as we all know, is 0, because 0 is neither positive nor negative. Let's go ahead and do the next vertex, which is vertex H. We have the order pair 4, 7. So in H prime, a reflection across the x-axis, the x value is going to stay the same. So originally it was 4 in the pre-image, and the image is going to stay 4. The y value was 7 on the pre-image, but because we're reflecting, it's going to become the opposite, so it's going to become -7. All right, be careful. The -y does not mean that x is going to be negative, because sometimes it can be positive. It's going to become the opposite. All right, vertex I, we got the order pair -3, -5. That's going to give us I prime. And the reflection across the x-axis, the x value stays the same. So in the pre-image, the x value was -3. The x-coordinate value was -3. And then the y-coordinate is -5, but we're reflecting, so it's going to become the opposite. So it's going to become +5. Our last vertex is vertex J. We got the order pair -7, -4. And that's going to give us J prime. Again, reflection across the x-axis. The x value stays the same, so it's -7 in the pre-image. And so the new coordinate is going to stay -7. And then the y value in the pre-image, the coordinate is -4. But because we're reflecting, it's going to become the opposite. And the opposite of -4 is +4. All right? So for review, we learned about our new transformation today, which were the reflections. And please remember that reflections, you end up with a congruent shape, and reflections are rigid transformations. The shape and the size of the pre-image do not change. Okay? Thank you very much for watching. If you have any questions, please let me know. Have a good day.